In physics, the second law of thermodynamics says that heat flows naturally from an object at a higher temperature to an object at a lower temperature. And heat doesn't flow in the opposite direction of its own accord.
One of the main uses of the second law of thermodynamics is to determine whether a process is spontaneous or not. Let's consider a few examples. Here, two gases are mixing together. Air is being leaked from a balloon, and the mass is falling down, and the hot tea is losing its heat. You can see that the process of moving from state 1 to state 2 will happen spontaneously, which means without any external aid. But what about the opposite process? Will that happen spontaneously? From your own experience, you know this will not happen, so this process is not spontaneous. However, according to the rules of energy conservation, or the first law of thermodynamics, even the reverse process is possible, because in both states, the energy is the same. So what is missing here? There must be one more law, which governs the direction of a process, and that law is second law of thermodynamics.
What I'm saying is that what Nathan has stated to be the second law is not, in fact, the second law, and it's not true. Hot does not always flow to cold. That's what he says.
It does. So where's your example that it isn't?
Okay.
Hang on. If hot doesn't flow to cold, what do you think hot does?
I can't wait to hear this.
Do you think cold goes to hot?
I'm not talking about. I'm saying in every instance, that's not true. There are other instances where the opposite is true.
Okay.
Okay,
So
and I'll
let's
show
see
that
one.
to you.
Okay.
Let's see one.
Okay, so here's an example of a horse running in a field. Okay, the ambient temperature is 76 degrees or 24 degrees Celsius. As the horse puts his hoof down, he's going to create friction, transferring, making the temperature gradient go in the opposite direction. It's going to go from cold to hot. His hoof to the ground.
Heat transfer goes from hot to cold, from hot to cold, from hot to cold, from hot to cold, from hot to cold. Heat transfer